Okay guys, I already know that we went through all of these, but I just wanted to mention that all of these have asymptotes. Remember, an asymptote is the line that the graph will infinitely approach but never touch. So yeah, this is a growth function because from left to right it grows, right, to positive infinity. But if you go backwards, yeah, it infinitely approaches the y equals 0 line, so that's why the asymptote's y equals 0. And that's the case with all of these top ones, right? This one right here is a growth function because it's going from left to right, it's going to negative infinity, and the asymptote is y equals 0. This one's a decay function because from left to right it decays to the value y equals 0. Here's the y equals 0. From left to right it approaches that value. Again, a growth function from left to right will approach either positive infinity or negative infinity from left to right. Growth function in the negative infinity direction, growth function in a positive infinity direction. Right here, it's, what, is it going to infinity? No, it's approaching 0. So this right here is a decay function. It's decaying to 0. And of course, the asymptote is y equals 0. Right here, also the asymptote is y equals 0 because it decays to a certain value, and that value is y equals 0. Okay? Some of us might be thinking, hey, that's growing. No, it's not growing. It's actually decaying to the value of y equals 0. It's going to reach that y equals 0. Actually, infinitely approach but never touch. How about down here? The asymptote is 3. Why is the asymptote 3? Because 3 is where this graph will infinitely approach going in the negative direction but never actually touch. And this is a growth function because from left to right it grows to negative infinity. This is not a growth function. This is a decay function. Even though it looks like it's growing, as you go up it approaches the value of 4, and that's why the asymptote is at 4, because it approaches that value y equals 4. So anyways, I really just wanted to go back and talk about asymptotes. The asymptote here is 1. The asymptote right here is negative 3. Y equals negative 3. So I hope we understand that. Also wanted to talk about these guys. We already said whether they were growth or decay. And all of these have the asymptote y equals 0, except one of them. Which one's that? This guy, right? Because this is the only one that has a k value of 10. So this guy, if you were to graph it, would infinitely approach the y equals 10. Y equals 10 line. The k value always gives you your asymptote. I hope that makes sense. Let's jump to actually graphing these guys. So here's the notes I handed out on Monday, and this is what we worked on in class Monday and a little bit today on Tuesday. I actually don't like this because I ended up dividing this side of the, or this side of the page is all growth functions and the other side's decay functions. And I actually like to talk about it together so you could actually see when we have a growth and when we have a decay. So here's everything that you need to know. Obviously, this is what we need to ultimately know. The a value is still the a value, which tells you if it's being reflected on the x-axis, whether it's vertically compressed or stretched. The b value tells you if it's a growth or a decay function. If the b value is greater than 1, then it's a growth function. If the b value is between 0 and 1, then it's a decay function, right? So what else? The h, we already know that the h is the left and right shift. And you always have to think opposite. Why? Because there's a minus sign right there. That tells us to think opposite. And the k value is the shift up or down, depending on what that number is. And whatever number you see at the end, you take it for what it is because it says plus. Right here we think opposite because there's a minus sign. Right here you take it for what it is, whatever you see, because it says plus. I hope that kind of makes sense. If I were you, I would take the time to read these through, maybe pause it and read it, right? Maybe scroll a little bit up, pause it and read it, right? But I'm going to go back to our worksheet, okay, which is here. And I want to graph some of these guys. Let's start with the most basic, y equals 2 to the x power. Okay, so it's really easy to do. You make a quick xy table, okay? and you plug in consecutive inputs. I'm talking about 0, 1, 2, 3, -1, -2, -3. You're not even going to use all these, but it's really easy to do. Whenever you plug in your 0 into the exponent, anything to the 0 power is 1, so your output is 1, okay? Now, you could continue to plug in 1 right here, plug in a 1, get a 2, plug in a 2, get out a 4, plug in a 3, get out an 8. Or the easiest thing to do is to look at the base. It tells you the pattern of your outputs as you're going down when these guys are in order. So it says 2, so if I take the 1 that I have right here and multiply it by 2, I get my next output. If I multiply it by 2, I get my next output. Multiply it by 2, get my next output, so on and so on. So as I'm going down, I'm using the base to tell me what to do to multiply it by 2. If I'm going backwards, it's kind of like the reciprocal of multiplying by 2, which is dividing by 2, which is multiplying by half, right? So when you say 1 times half, what is 1 times half? It's 1/2. 1/2 times half is 1/4. 1/4 times half is 1/8, right? And that beats the heck out of actually plugging in a -3 right here, getting 2 to the -3, and then having to move it down because it's a negative exponent and getting the fraction 1/8 anyway. Let me just quickly graph those coordinates. So here's 0, 1, and there's 0, 1. And then I move on to 1, 2. 1, 2 is 1, 2, there it is. And then if you go to 2, 4, there it is, and 3, 8, there it is, the 2, 4, and 3, 8. Okay, so we have this growth function from left to right. Now if you're going backwards, as you could see, it's getting smaller and smaller and smaller. At -1, if you're at the origin, go -1, you're at 1/2. If you go to -2, you're going to be at 1/4, which is half of the half. So I could zoom in right here greatly. So that would be 1/4, which is right there. And then the next one would be half of that, which is 1/8. And then the next one would be 1/16. And you can't really see the difference anymore, so you might as well just draw points on the x-axis, even though we know that it doesn't ever actually touch, it just infinitely approaches. So our graph is going to be that. Okay, the asymptote is at y equals 0. Very easy to do. Okay, now let's compare that with any of these other ones. Let's do this one right here. Okay, so if we graph this guy, we're going to again make an XY table. We're going to plug in 0, 1, 2, 3, and -1, -2, -3. Okay, so when we plug in 0, we get the output. When we plug in 0 right here, we get the output, the A value, because 2 to the 0 is 1. So you really end up with 1/2. So when you plug in 0, you get out a 1/2. Okay. When you plug in 1, what do we get out? Now you could go through the motions and plug in 1, plug in 2, plug in 3, work it out, multiply by half, get all these different answers that go over here. But the easy thing to do is to look at your base and let that guide you with the pattern on your outputs, only because these guys are consecutive inputs. So if I plug in, not if I plug in, but looking at the base, it tells me to multiply by 2. So if I did, in my head, go 1/2 times 2, that's going to give me a 1, and that'll get me here to the next one, right? That's how I got to the 1. If I multiply by 2, it's going to be 2. If I multiply by 2, it's going to give me 4. And I could even keep going here. If I multiply on the next one for the 4, if I multiply by 2, it's going to give me 8. So those are all coordinates that I simply came up with by understanding that the base tells me the pattern of the outputs, multiplying by 2 as I go this way. As I go back that way, it's not multiplying by 2, it's actually multiplying by half. Or you could also think of it, as I'm going this way, I'm multiplying by 2. As I'm going backwards, I'm going to be dividing by 2, which is really multiplying by half. So think about this. 8 times half gets me to the 4. 4 times half gets me to the 2. 2 times half is 1. 1 times half is 1/2. 1/2 times 1/2 is 1/4. 1/4 times 1/2 is 1/8. Okay, and if you don't see it, just think about this. Imagine this. Times 1/2. Oh, okay. Well, 1 times 1 is 1, and 4 times 2 is 8. So keep going. 1/8 times 1/2, well, that'll be 1/16. But at the end of it all, it doesn't matter because we know it's going to infinitely approach 0 if we go in the negative direction. Okay? Now, when we graph these guys, you really only need a couple of these Not all of them. So let's go with 1, 1, which is right here. I forgot the 0, 1/2, I'm sorry. 0, 1/2 is right there. We go to 2, 2, 2, 2 is right there. And 3, 4, 1, 2, 3, 1, 2, 3, 4 right there. Then 4, 8, 1, 2, 3, 4, 8 is all the way up here. Okay? And of course, as we're going this way, we know it's going to infinitely approach 0. So I might as well just draw my asymptote right there touching the x-axis, like if it were touching the x-axis, even though we know that it never actually touches. And then this way, just draw your lines right through those coordinates, and you're done. That's your exponential growth graph. Okay, now for the hardest part, understanding how to put it all together, understanding A, B, your A, your base, your H, and your K. Okay, this guy up here. Okay, so let's jot down some notes. So we have these steps right here. First, identify H. First, identify H and K, and then ignore them and graph the parent graph. Okay. So we're going to first identify H and K, ignore them, and graph the parent graph. So looking at this, what is H and K? H is positive 1. We have to think opposite because there's a minus sign in front of H. So we have to think opposite. So H is positive 1, and K is negative 3. Now, what does that mean? It means that your H, you're going to be shifting 1 to the left and 3 down. So here we go. We've already identified H and K. Now, let's simply make an XY table. Let's ignore H and K. I'm going to ignore H and K by doing a box around the function, but not including the H and the K. So I'm just going to focus in on the 4 times 2 to the x power. And I'm going to do, like always, do the inputs. Here's 0, here's 1, here's 2, here's 3, and then negative 1, negative 2, negative 3. Okay, so when I plug in 0, I'm going to get my A value of 4. When I plug in 0, I'm going to get the A value of 4. So I'm going to put a 4 right there. Okay, when I plug in 1, instead of plugging in 1, I'm going to listen to my base. Base. Okay, that was dumb. I'm going to listen to my base, which is 2 right here. Okay, 2. So what does that tell me to do? The 4, if I multiply it by 2, it'll give me, if I multiply the 4 by 2, it's going to give me my next output, which is 4 times 2, 8. And if I multiply by 2, it gives me 16. Multiply by 2, 32. Now, we know that we're not even going to use these guys because that's a 10 by 10 graph, and that's already off the graph. Going backwards, instead of multiplying by 2, which is going this way, I'd have to divide by 2, which is going that way, which means that's really multiplying by half. So if I take 4 and multiply it by half, well, I would get 2. When I take 2 and multiply it by half, I get 1. When I take 1 and multiply it by half, I actually do get half. And if I take half and multiply it by half, I get 1/4, and then 1/8, and then 1/16, and it keeps getting smaller and smaller. Anyways, let me graph these coordinates. So here we go, graphing them. The 0, 4 is right here. The 1, 8 is right there. The negative 1, 2 is right there. The negative 2, 1 is right there. The negative 3 and half is right there. And we already know what happens. It's going to keep going till it looks like it's actually on the y equals 0 line. So I'm not actually going to draw a line through this. Why? Because it's not the real graph that I want. This is just the parent graph. What I need to do is listen, or actually go back and look at my H and K and move every single one of these coordinates 1 to the right and 3 down. Every single one, 1 to the right, 3 down, 1 to the right, 3 down, and we're going to have our new final graph. So if we do that, 1 to the right and 3 down, we end up with those new points. If we, like I said, moving 1 to the right, 3 down, 1 to the right, 3 down. And we also need to shift that asymptote that's at 0 3 units down, which would end up right here. Whoa, got kind of crooked there. So that's my new asymptote. To graph this, all I need to do is go right through those dots, and that is my final graph. This one was not. That was just my parent function. So to wrap things up here, guys, again, you identify your H and your K, think opposite on H, take K for what it is, graph, ignoring H and K, your parent graph, get all these coordinates, plot them, and then move them according to H and K to get your final graph.